Chapter 4, Task 3, Finding Solutions by Substitution. The substitution method is most useful for systems of two equations and two unknowns. The main idea here is that we solve one of the equations for one of the unknowns and then substitute that result into the other equation. And when I refer to unknowns, I'm talking about those variables, meaning x or y typically. So the substitution method can be applied in 4 steps. Step 1 is to solve one of the equations for either x or y, those unknowns. Step 2, we're going to substitute this into the other equation. Step 3, we're going to solve for the variable in the new equation. And then step 4, we're going to find the other variable by substituting the number you found in step 3 into either of the original equations. This will all make sense when we do these examples in just a second. Please note that it does not matter which equation we choose first and which we choose second. You're just going to choose the one that looks like the easiest one to solve first. And once we have solved for x and y, your answer is going to look like this in the format of the coordinate point of x, comma, and y. So let's start with our first example. We're going to solve the following systems by substitution, is what the directions say. So step 1 says to solve one of the equations for either x or y. Well, good note about example 1 and 2 is that each of these provide an equation where that step has been done for us. And I do want you to write this note here because it's super, super important. And if you have a highlighter or different colored pencil, I would even highlight so that you can see x is all by itself on example number 1, and y is all by itself on example number 2. And what I mean is there's no number in front of it. There's no coefficient. So step 1 done for us, yes. Let's move on to step 2. It says substitute this into the other equation. What I like to do, and I am going to erase this just so this doesn't get cluttered here. What I like to do is actually physically circle what I'm going to be substituting in for x. A substitute takes the place of something else, just like a substitute teacher comes in and fills in. So we're going to actually take what I circled and plug it in the other equation for the x. So I'm going to rewrite everything in this first equation here, except I'm going to leave me a big space where the x goes. I'm going to rewrite everything else exactly as it is. And I'm going to physically sub in what I circled for the x in place of that. So I'm going to write 4y minus 2 because that's what I circled, identified there. I want you to notice right now that now we have an equation that only includes one variable, and that variable happens to be your y. Now we can solve. And when we solve, we're really at step 3. It says to solve for the variable in the new equation. This is our new equation. So now it's just following order of operations. So I see we have parentheses, so we're going to distribute the 2 to everything within the parentheses. And this part should look familiar. After we distributed by multiplying, we now have to combine like terms. So I underline my like terms on the left. 8y take away 3y is 5y. Bring down everything else I haven't used yet. Now we're at a 2-step equation. Do the opposite or inverse operation of add 4. Should we subtract? I bring down everything else. Oh, I made a mistake, didn't I? 2 times negative 2 is actually negative 4. So this guy right here should have been a negative. I should have brought a negative down. The opposite of minus 4 is, that's right, add 4. 6 plus 4 is 10. 1 stepper here, divide both sides by 5. And I know 10 divided by 5 is 2. So I am about halfway done with this system of equations. I've solved half of it. I have solved for the y. And remember, our final answer is going to be a coordinate point. So I'm just going to go ahead and already plug in what I know. I know that the y is 2. So I now have to go back up to step 4. It says find the other variable by substituting the number you found in step 3, which is what we just did, into either of the original equations. Remember, I said it does not matter which equation you choose. I like to do what's easiest. So if we take a look at both of these equations, I would have to do a little bit more work on the first one. I don't want to do more work. So I'm going to go to x equals 4y minus 2 because the x is already isolated, and that's what I'm trying to find. But instead of writing the x, I'm just going to leave a space there. And I'm just going to give you a box now for a minute. So I'm not going to write the x. All right, I take that back. I was going too fast. I am going to write the x because I'm trying to find the x. We know the y. So I'm going to write x equals 4 times space. So I'm actually going to plug in that 2 right here. And then I'm going to rewrite minus 2 because that was the equation. So let's go ahead and do that. X equals 4 times 2, which is 8. And now I have a one-stepper. X equals whatever 8 times minus 2 is. We know that's 6. Final step, plug that guy down here. And that is our final answer. All right, again, we already identified that step 1 is done for us. Y is all by itself. So I'm going to actually circle what we're going to be subbing in for y in the other equation. I'm going to write everything exactly as it is, except I'm going to leave this nice space for what I'm plugging in for y. 3x minus 14 goes in that space. So now we're going to solve because we are down to one variable. Bring down my x. I can't do anything with it yet. This negative on the outside, by the way, of this parentheses is like a -1, so I have to distribute it to everything within. -1 times 3, -3 with an x, -1 times -14, so positive 14. Notice we're down to one type of variable. We do have to combine like terms. Two-step equation. And after we go through the solving process, we see that x equals 6, halfway done. Now we've got to plug in our x value to find our y, but I'm going to already record what we know. Since x is 6, that's part of our final answer. So again, I'm going to go back up to look at our equations. I'm going to, for me, look at which one is easier. Since I need to find the y is already isolated, so for me, I'm going to choose the second one. But this, again, is you can choose either that you like. Y equals 3 times, I'm going to give a space for the x because that's what I know. And I'm running out of room here, but I'm going to plug the 6 in to my unknown. And then I'm just going to solve. In this case, y equals 4. So let's plug that final answer in here, and we are done. Okay, so now that you've flipped your note page over, you'll notice in these equations that step 1 is not done for you. So we're going to have to do a little work to isolate one of these variables. And again, I look at which is going to cause me the least amount of work. So 2x plus y equals 20. There is a coefficient in front of the x, so I probably don't want to solve for x in this occasion. Y doesn't have a coefficient, so I think I'm going to choose to solve for the y in the first equation because the second equation has a coefficient in each of them. So that's my thought process. You can do either, but that's where I'm going to start. And just note that no matter, as long as you do the math practices correctly, it doesn't matter. The end result will be the same. So I'm going to choose to solve for y first. Well, right now, y has 2x being added to it. So I'm going to do the opposite of 2x. I'm going to rewrite the problem down here so you can see the math. So to get y all by itself, I'm going to take the 2x to the other side by subtracting it. That cancels it on the left side, and I'm left with y equals It is not 18x. What's happening here is this doesn't have a variable and this one does. So I'm just going to rewrite it, 20 minus 2x. Now I have y all by itself. So just like I did in the other examples, I'm going to circle what I'm plugging into the other equation for the y. So the other equation on your notes was correct. I had to make a correction. It should be equal to 12. So I'm just going to rewrite everything except for the y. 6x minus 5, the space for y equals 12. I'm going to substitute what I circled in for the y. And again, we do that so that we're only dealing with one variable. And as you can see in this step number 2, I have only x's to deal with, which is good. So in this step, we need to distribute the -5 to everything within the parentheses. And after we do that, we have -100 plus 10x. In this step, we're going to combine like terms, so I underlined what was alike, my x's, so I add them. 6x and 10x is 16x. I just brought down everything else I didn't use. At this step, we take -100 to the other side by doing the opposite. We get 16x equals 112, divide x is equal to 7. So I'm going to go ahead and record the first part of our answer. X is 7, so it goes in my first slot of my coordinate point. I'm going to take that, just like we did on the reverse side, and plug it into either equation. Remember, this is your choice. Since we're looking for the y, to me, it looks like the first equation would be easier because I have y without a coefficient. So for me, I'm going to go ahead and choose the first equation, but I'm not going to write the x. If you recall, we just found it. I'm leaving a space for it. And I'm going to plug in 7. And we're going to do that. Opposite of a positive 14 is negative, so I'm going to minus it. Y equals 6. We have found both our x and our y, so our solution by using substitution is 7, 6. Last example, and again, step 1 is not done for us, but when I look at each equation, to me, I would start with the second one because the y doesn't have a coefficient. So in this case, I'm not going to rewrite it. I'm just going to solve for y since it's on the bottom. The opposite of a minus 4x, which is plus, 5x, which is plus 5x. That cancels. Now I have y all by myself, but just remember you cannot combine those two terms because they're not alike. But now we have isolated the variable and we can plug it into the other equation. I'm going to plug it into that guy right there. So now we're on step 2. I just rewrote the first equation, but I left a big space for the y because I'm substituting 5x plus 13 into the y. So I'm going to put that right here. Let's go ahead and solve. So after we distribute, we get 15x plus 39, combine like terms. We're left with 12x plus 39. Take 39 to the other side by subtraction. We're left with 12x equals negative 36. Divide by 12 on both sides, and we're left with x equals negative 3. So we have isolated the x, so I'm going to go ahead and put him in our answer. Since we know what the x is, we have to go up to the other equation and solve for y. So I wrote the other equation, but I left a space for the x because we're going to substitute that negative 3 in for x. Now we only have one variable left to solve for. Go ahead and simplify it. By multiplying, now we take negative 9 to the other side. We're left with 3y equals negative 6. One step left to go is to divide. And that says 3y equals negative 6. When I divided by 3 on both sides, that's a 3. That's pretty sloppy, but that is a 3. And I know that negative 6 divided by 3 is negative 2. So our final answer to this system of equations is the coordinate point negative 3, negative 2. Leave that.